In this video, I'll be working through the question you can see on the screen here from the summer 2025 Cambridge A-Level Maths paper 2-1. I'm going to try and show you how to do this question and not just the solution. So definitely pause and rewatch certain parts of the video as you need to. If you're looking for a different question from this paper or a different paper entirely, have a look in the description below. You should be able to find a playlist there or have a look around on my channel. Okay, let's get into the maths. In question 3, we're given two different equations and we're asked to sketch them on a single diagram. Now there's only 2 marks for this, so you shouldn't spend too much time in this question, but I am just going to take my time to teach you how to do it. If you just know what a function like this looks like and you just know what this function looks like, you're fine. That's okay. I'm gonna hopefully teach the student that's okay at remembering some functions but not quite good at remembering them all. So here's how I would do this. I'm going to draw lots of pictures before drawing the final one. First of all, what does forget this, what does e to the power of x look like? This is something you do need to remember. Some of the basic functions you do need to remember what they look like. It looks like this, goes up there quite quickly and it hits at 1. Think of you can always find this point quite easily by putting 0 in. If you put 0 in here, anything to the power of 0 is 1. It'll look like this. Let's draw a few more. What about e to the minus x? I'm just trying to get it closer to looking like this. E to the minus x. Think of what happens when you change this sign. When I put in minus a million, I get this. When I put plus a million, I get up over here. So if I put in minus a million, that'd be minus minus, I'll get the plus, I'll get whatever's up here. So I'll actually get something up there. If I put in a million, I'll actually get what minus a million would get here. I'll get something down here. It's just we get the opposite to that, like that. That's still at point 1. Stay drawing here. What about e to the minus 2x? It'll look identical to this, except it'll just go a little steeper. Instead of going up steep, it'll go up even steeper again. And then finally we'd have 3e to the minus 2x. It will go up steeper again. Multiply everything by 3. That'd be a 1. This will now be a 3. That's really the idea we want to get. And it's okay if you're able to do that straight from the beginning. Alright, this one's a little easier. First we need to remember what secant is. Secant is equal to 1 over cosine x. Again, it's okay if you just know what secant looks like, but I'm not very good at that. I'm going to draw cosine first. Cosine x. Cosine x looks like this. And we'll do it both ways out here. So what does 1 divided by this look like? This is a 1 here. 1 divided by 1 is 1. 1 divided by, say, a half, that's 2. So it actually goes, when this goes down, this goes up. 1 divided by 0, and that's the real clue. 1 divided by 0 goes off towards infinity. So we get this shape here. 1 divided by minus 1, we get a minus 1. 1 divided by 0, again, goes off to infinity. We get this shape here. Let me just draw a few of these in. I probably haven't lined them up. This 0 should be, I haven't lined it up very well. We get this sort of shape. This is what secant x looks like. We really want to combine this with this one here. It's not as hard as it looks because they only wanted us to draw between 0 and pi over 2. This is, let's go up to this one. This is pi. No, that's not right. It is. That is pi and this is 2 pi. Pi over 2 is here. That's pi over 2. That's at this point here. That's pi over 2. Pi over 2 is just the number. What's that? 1.57? Whatever it is. It doesn't really matter. Just pi divided by 2. Somewhere here. It doesn't really matter because the shape just says the same. So you combine these two. Let me squeeze the actual answer in here between pi over 2. They would want this shape here starting at 3 and they would want it to come down. That's it. And they would want this shape here starting at 0. Starting at 1. 1 here, and they would want it going up like that. Actually, that can go off to infinity there. That's really all they're looking for those 2 marks. They want to see pi over 2. Sorry, let's say come down like, let's have it like that maybe. They want to see pi over 2, they want to see the number 3, they want to see the number 1, and this going straight up like that. That's your full marks for 3 part A. Hopefully that helped a little. I'm sorry if it was a waste of your time, but if it was, you probably just skipped it. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Just to reiterate, part A, this is the full answer for part A. This will get you full marks. I'll leave it there because I'll reference it again as we go on. Okay, for part B, they want you to show that the x coordinate, the point of intersection here, is x is equal, let me write that out, is x is equal a half natural log of 3 cosine x. They want you to show that. Where did that come from? The clue here is the intersection of these 2 curves. It's when this equals this. They want you to put this one equal to this. Sorry, I've changed this one, by the way, from secant to 1 divided by cosine x. I just do that all the time, and it's clear it's what we should do because it's cosine is in what we need. In fact, I never use secant, I just don't like it. So let's just put them together. We get 3e to the minus 2x is equal 1 over cosine x. They want you to rearrange this so x is on its own and it equals all this. You have 2 choices of which x to get on its own. This one, but that means getting rid of cosine, and we want cosine, so that's probably not the one. Or this one, and that means getting rid of e, which there's no e up here, and when you get rid of an e, a natural log appears. So it's this x they want us to get on its own. You've a couple of choices how to do this. One thing that jumps out at me is rewriting it as 3e to the 2x like that is equal 1 over cosine x. Multiply across, so we get on the left 3 cosine x, which is good because we want 3 cosine x, is equal to e to the 2x. Now we can just take the natural log of both sides. Let me write this side first. Natural log of e to the 2x is just 2x. Natural log destroys the e. And natural log of this side is natural log 3 cosine 2x. No, it's cosine x, sorry. I don't know where 2 came from. And x, 2x over here. X then is equal a half natural log 3 cosine x, just like they asked for. That's your full marks for part B. In part C, they ask you to use an iterative formula based on the equation in part B, and to find basically to find the answer. To tell you they want it to 3 decimal places, but give each iteration to 5 decimal places. This should all be sparking a bell because this question comes up every year. You should have studied it, you should have practiced them. They're slightly different time and time again. Usually they give you the iterative formula. In this case they haven't, they've just given you this, so you just need to change this ever so slightly. It just becomes xn plus 1, or sometimes some people use xn here, is equal to a half natural log of 3 cosine xn. Again, some people use xn and n minus 1. I just use n plus 1 and n, just a slight difference. Either is an iterative formula. That's the first thing they want you to do. I think they'll probably give you a mark just for doing that. And from this point, it should be the same as you always do. What you want to do is you want to make a guess at an answer. Sometimes they give you that first guess. They haven't in this case. You just want to make up a guess, and then for x1, your next guess, this formula will give you your next guess. This formula will be a half natural log 3 cosine whatever your first guess was, and it'll give you your second guess. You do it again, x2, and you put it in the formula again. Your second guess goes into the formula. It gets you your third guess. You stay going, and this formula will give you a better and better guess each time. Usually it takes about 3 or 4 guesses. The number I started with, it actually took me 10 guesses, which is a little annoying. I started with, so once your number is anywhere between 0 and 1.57, like that's all you really need. So 1 could be your guess. I just took somewhere in the middle. I think I started with 0.75. Honestly, any number. We'll get different numbers as we go through the question, but we should all get the same final number. So this is your first guess. You put this into this formula, and the calculator will spit out your second guess. Again, you could call this x1 if you want, and x2. I just start with 0. It must be the way I learned just. So when I put that in, I get as my next guess 0.39311. That's five decimal places they asked for. But I also like to write in 3 decimal places, because that's what our final answer is going to be. When this number repeats itself, when your next guess is the same 3 decimal places, you've gone far enough, and that's a good enough answer. Okay, you need to put this out every time. Like I said, it's going to take 10 guesses, so you need to put this in your calculator 10 times, which is a bit annoying, but there is a quicker way. Let me write it here. If your calculator has this as the final answer, or this, I often just put this one, 0.75, and I press equals. This is now remembered as your answer, or in this case, this is your answer. It doesn't really matter. What you can do, you can put in your calculator a half, natural log, 3, cosine, and in here, instead of putting in the number you want, you put in, there's a button on your calculator that just says answer. And what it will do is it'll put your previous answer in. And so you will just get out, you're not saving yourself anything yet. In this case, you'll get a 0.963 or 50963 or 0.10 to 3 decimal places. Now the advantage of doing this in your calculator is if you press equals again, let me put it down here, x3, if you press equals again, it will automatically remember this is your last answer and this is the formula they're dealing with. So it'll just give you can just press equals a few times and you'll get the answer you need, although you do need to show the examiner each number. So in this case I get 0.48135, which is 0.481. These aren't repeating yet. They're in fact miles off each other. So I just have to stay going. You know what, let me write out all the numbers I got and then I'll talk about what we found. Okay, so this was a nasty question. It's only the second time I've ever seen a question come out this long. It took a lot of writing to do. I really wish I had guessed 0.5 because that's quite close to the final answer. So here's what happened. Each number I got, they never repeated. So I never thought, oh, I'm at the right answer. 0.487 did repeat, but with 88 in the middle. And then 88 repeats. So I know the answer is around there. It keeps jumping around this number. I know it's roughly the right answer. But until I get 2 of them repeating, I don't know where exactly the right answer is. But that's what you should have got no matter what you started with. You should have finished off with 0.487. If you did start as 0.5, I guess it would have been a little quicker, but not really. I guess I was at 0.5 on my second guess. So honestly, it's just one of those, they sort of, it just takes a while to narrow in on it. Okay, that's it for question, what are we on? Question 3. If you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day.